All right, so far when we talked about Chapter 5, and what we've done in Chapter 5 is solving systems of linear equations by graphing, substitution, and elimination. Because we've had these three different methods for solving systems of equations. Now, out of the three, some of them work better than others. Some of them have a better or more useful way to solve systems of equations. Now, graphing, if we're given two equations, both in the form a, y equals ax plus b, and a, the slope is not a whole number, if we have fractions in both, or one of them, it's going to be a lot easier to graph it. It's a lot easier to work with it graphing-wise, because we have the y-intercept and the slope, and we can graph them and see where they intersect. So if we have two equations in y equals ax plus b form, most likely it's going to be easier to graph them than it is to use substitution or elimination. Now, substitution, if we have an equation, one is y equals everything else, or x equals everything else. If we have one or the other, or a variable by itself already, so y equals or x equals, it's going to be better or easier to solve it by substitution, because all we have to do is plug this in or plug this in to the other equation and solve. And elimination is kind of the catch-all everything else. If they're both not set equal, y equals, and we don't have a variable already by itself, then we're going to use elimination. So elimination is almost the catch-all if graphing and substitution really don't work well. Okay. Now what I want y'all to do is I want you to work on this one here. So I'm going to give y'all 7 minutes here, 6-7 minutes. So at 2:35, we're going to come back together and work this one here. Okay? So I want you to figure out, so is it going to be better to graph it? Use graphing, substitution, or elimination to solve this here. Number 2. So let's look back here at number 1. I know some of you have moved on to number 2, but let's look at here at number 1. Now when we look at number 1, what is going to be the best method to solve this one here? Substitution, elimination, or graphing? I would say graphing, yes? Because we have them both as y equals. Now, for this here, I already got a graph paper up here for the smartboard. Okay? So, we're going to graph the top equation. So what did we do first to graph this equation here? So, yeah, we went to 4 on the y-axis and made a point, yes? Because that's where the y-intercept is. And then what? Okay. 1, 2, 3. 1, 2, 3, 4. And how did I know to go down 3 and over 4 to the right? So why did we know to go down and then right? Because the slope is negative. Negative. Because when the slope is negative, the line is going to be decreasing from left to right. So it should be going down. Now at this point here, we can draw a line through it. Now, on some, we might do multiple points just to see multiple different spots. We have this here. So you went this direction? Yes, just a little bit. Mm-hmm.
Maybe this one. Yeah, this one. This one's the one that's.
Yeah, I think you went over 4. Yeah. Let's see how we get this here. So let's look at the bottom one. So this one here, well, we have the -1, yes? So that's our y-intercept. So where would I go to get that point? Where do you think we would go? So up 1 and over 2? Well, we are going to do that, yes. Because that would be our slope. Our slope is 1/2, so we would go up 1 and over 2 to the right. Now, this here, the -1 is our y-intercept. We need that point first. Now, the y-intercept is where it crosses the y-axis, and that will always be this line here in the center. Now, where is it saying it's crossing it at? So I come to this line, the y-axis, and I find out where -1's at. So that will just be one down from that middle. Questions on this here? Now we would do yes. From here, we would go up 1 and over 2. And if we did it again, well, those two lines would meet at that point, yes? So the point of intersection where they meet is right here. Well, the x value is 4 and the y value is 1, because it's over 4 and up 1. Questions on this here? Does this make sense? Yes? Okay. We could also draw that line. Okay. Work on number 2 now. So looking at this one here, guys. Now this one here is kind of nice because it already has one x equals a number, yes? So that works out well. So I would use substitution because I do have a variable. So if we plug it in, -4/3, 3 plus 1, we substituted 3 in for x. Because -4/3 times 3 will give us -4. And that's it, because it already gave us the answer.
Number 4, can you do number 4?
All right, we'll put that right there. We'll do number 4 here in a second. Or we can look at number 4 here. Because I think, are we good with foot number 4? We're looking at number 4. Now, if we look at number 4, well, do we have either one of those equations as y equals? Both of them as y equals. Well, no, we don't have that, and we don't have a variable by itself. So graphing would be a little tricky. Substitution would be a little tricky because we've got to do a lot to get to one of those, yes? So what's left? Elimination. So graphing and substitution really don't fit well if we don't have a variable by itself. Or both of them as y equals, we're going to do elimination. Now, if we're looking at elimination, we want what? We want either the x's to have the same value in front of them or the y's. And we normally get that by multiplying one equation by a number or the other. So if I look at, say, the x's, can I multiply something by 3 to get 8? Well, no, because 3 times 2 is 6, 3 times 4 is 12. It doesn't work out well. Let's look at the other one. Can I multiply 2 by a number and get 3? Well, no. So I can't multiply by a number. So we have to pick a variable. Do we want to eliminate x or y? So we can eliminate y. Any questions on this here so far? So if I'm going to eliminate y, I'm going to multiply both of them by a number. Now the top one. So I have 2y and I wanted 2y and 3y to be the same, yes? Well, so the value of y on bottom is what? 3, yes? So I'm going to multiply the whole top equation by 3, because 2 times 3 is what? 6, yes? What's 3 times 2? 6, yes? So I'm going to multiply the whole bottom equation by 2.
Oh, I thought you had it by the same number.
We can do each one by different numbers. We normally, it's really nice if I only have to multiply one equation by a number, but sometimes I have to do both. So the easiest way to get the numbers to be the same as well, okay, well this has a 3, so I'm going to multiply the top equation by 3. Well, the other equation has 2, so I'm going to multiply the bottom one by 2. to get them to be the same. So I'm going to multiply the top equation by 3. Three times 3x is 9x. 3 times 2y is plus 6y. And 4 times 3 is 12. Now we're going to multiply the bottom equation by 2. And again, we multiply through by 2. 2 times 8x is going to be 2 times negative 3y is going to be negative. And negative 6 times 2 will be negative 12. We have a variable in both equations that's the same. We have 6y and 6y, don't we? And that's kind of the goal with elimination. We want one of the variables to have the same number in front of it. Any questions on any of this here? Any questions on how we got to this point? Okay. Now what I'm going to do is I'm going to put the equations over the top of each other. So 9x plus 6y equals 12. Now, if you're wondering which question, or wondering why I put a certain equation on top and one on bottom, it doesn't matter. We're just picking one to put on top, one to put on bottom. We just put them there. Any questions on this here so far? So which ones have the same number? Well, the y's, yes? Are those signs the same? Yeah, the non-variable numbers do match up. Are the signs the same on it, though? No. If the signs aren't the same, we add. And if you're not sure and kind of wanting to see, is it addition or subtraction? And just take one and guess. So adding. So we can look at it, or say subtraction. Well, is 6 minus negative 6 0? If it is, then that's what we want. If it's not, we want the other one. And 6 minus 6, negative 6 is not 0. But 6 plus negative 6 is 0. These will cancel. Because what are we wanting? We're wanting one of the variables to cancel out. Now 9 plus 16 is going to give us 25x. That would be 0. 12 plus negative 12. These would cancel out and give us 0. So when I combine those two equations by subtracting, did one of the variables cancel out? Yes. One of the variables canceled out. So now we can solve for the other, yes? So what can we do to solve for the value of x? We can divide both sides by 25. I'm going to take 25x equals 0. And we can divide both sides by 25. 25 divided by 25 is 1, so I'm left with x. 0 divided by 25 is 0. So we have the value of x, but what do we still need? The value of y, yes? Okay. Right? So we can use the top equation. I'm going to have to erase this here. So we can use the 3x plus 2y equals 4. And I'm going to plug 0 in for x. Well, 3 times 0 plus 2y equals 4. Well, what is 3 times 0? 0. Do I have, this whole thing becomes 0, yes? So 0 plus 2y equals 4. Wait a minute. Do I need to even write 0 plus? No, because 0 doesn't add anything to the equation, does it? No, so we really don't need this. It's gone. So what do I need to do at this point? So y equals 2. So our point, our solution is 0 2. Our point here is 0, 2. I want y'all to work on number 3, because I know we skipped it. Work on number 3. And yes, I see some of y'all going for this graph paper. I would graph it. I would graph it. If we graph this one here, -3, up 1, 2, 3, 4, over 9 over here.